Hello, good evening, everyone. Am I audible? Can anyone of you reply?
Yes, sir.
Thank you, Singh sir.
Yes, sir.
Yeah. Thank you, Parimal Alayaru, sir. Okay, let's wait for another 5 minutes so that some of
Audible,
the
sir, audible.
officials can join. Okay, we are doing the YouTube streaming simultaneously. Those who are not able to join can join the YouTube also. Sir, I'm changing the slides. Sir, I'm changing the slides. Can you tell me that it's visible to you? Sir, can anyone of you tell me that it is
Yes,
visible to
sir.
you?
Yes, sir. Visual.
Okay, thank you, sir. Thank you. Good evening to everyone. My name is Sasi Kumar. I'm working as JTO and BSNL from 2002. My area of expertise is optic fiber transmission as well as computer networking. In today's session, we are going to see about optic fiber cables. Okay. Please excuse me in the middle. I have to stop sometimes because I have to admit all the officials in the meeting. Okay. Okay. Optic fiber cables. Okay. What is optic fiber cable? It is nothing but one of the medium which is going to act as a transporter to transport the information from one point to another. Okay, what is information? Information might be anything. It will be converted into zeros and ones. Those zeros and ones are transmitted from one point to another point. For that, I need a medium. That medium is the optic fiber. This optic fiber cable can transmit any optic signals in the form of light, that is especially laser or LED, to a longer distance. That is the thing we are going to see. Before going to the session, we can see a small demo why we require optic fiber cable. Okay. Now I'm going to command mode. Is it visible to everyone?
Yes, sir.
Okay. Now I'm going to give a command call Amazon.in. Okay, I'm going to go ping Amazon.in. Okay. Now I'm getting a reply 54 239 33 92. This is the IP of the Amazon server. Okay, this Amazon server, I'm sending 32 bytes. The time taken to reach the Amazon server is 162 milliseconds. That is, I'm sending a packet and getting a reply. That is 162 milliseconds. Okay, let's see 54 239 33 92. Let's see where this IP is available. Okay, now you can check it. I'm going to what is my IP. Now I'm going to check where the IP is, where that IP is available. 239 33 92. 239 239 93.32. Okay, now I got a reply. Okay, this IP 54 239 93 32 is available where it is available. You can see it is available in Washington. So it's in US. That means that Amazon.in server is available in USA. From here to USA, I'm going to send my data. For example, if you are booking something in your Amazon app, okay, you are booking something, that data has to reach the Amazon server. For reaching that Amazon server in USA, I'm taking only 162 milliseconds. Okay. This is how. And now we can see. Okay, sir. From India to reaching USA, how I can reach? Okay, I will be having an optic fiber cable in the underground. Okay, this cable is laid from Chennai to Singapore. From Singapore, it is going to Middle East. From Middle East, it is going to Egypt. From Egypt, it is going to Morocco. From there, it is going to Spain. From the Spain, it is going to Ireland. From Ireland, it's coming to USA. From USA, it is coming to Washington. From there, it will not stop. It will come through this area and it will be coming through the IST standard time. It will come into Philippines, it will coming to Malaysia and once again Singapore, Singapore to India. It is a ring topology. Okay, I'm going to have the ring topology. Okay, this is how the optic fiber cable is connecting throughout the world. Okay, now we are going to see about that optic fiber cables in the session. It's just a small introduction session. Okay, now we got an idea. Okay, why we want to see about the optic fiber cables. Okay. Because are you able to follow me? Why we are going to see about the optic fiber cable? What is the need?
Yes,
Okay.
yes, sir.
Apart from this, we are using optic fiber cables in different places. Nowadays in cable TV we are using. Okay, in case of set-top box, home set-top box, TV set-top box to your speaker, we are using optic fiber cables. Apart from that, we are using in AI cars, AI devices, which are having a lot of sensors. Those sensors are connected through optic fiber cables. Okay, it's a plastic fibers, the plastic optic fiber cables. They are connected. The sensors are connected to the optic fiber cables. Why? Because the data has to be more precise and it should be transmitted much faster. Okay, nowadays cost is not the main thing. Everyone needs much faster. That is possible only because of the optic fiber cable. As I told you, optic fiber cable is nothing but it is a medium which is going to transport the information from one point to another point. It's like our public transport bus. You'll be going to a bus stand, we'll be getting into a bus. After that destination, we'll get down and we'll be reaching our final destination. In the middle, the bus is going to take care of the information. This is how the thing is going to happen. Okay, we are going to see about a small introduction about the optic fiber cables. Okay, this is an two images I have given in this slide. Okay, on the left hand side, I'm having a ship. Okay, the ship is loaded with the optic fiber cables. This is how I'm going to lay the optic fiber cables throughout the world in undersea. Okay, laying optic fiber cable in land, you might have seen. Okay, they'll be digging. Nowadays, horizontal boring is happening, all these things. Okay, what is inside the optic fiber cable? Okay, as I'm telling from here onwards, optic fiber cable means just you have to imagine the image on the right hand side. Okay, I'm going to have a core, I'm going to have a cladding. Both are solid glass. Okay, both are solid glass. There is no hollow, it's a pure solid glass. Okay, the light is going to travel only inside the core. Light is going to travel only inside the core with the principle of total internal reflection. The principle called total internal reflection. That is the totally it is going to travel only inside the core. Then what is the purpose of this cladding? This cladding is an impurity coating material which is going to reflect the light. When light is going to tend away from the core, the cladding will reflect the light once again inside the core. For example, if I can see in the coming slides. Okay, this core and cladding is the main thing of an optic fiber cable. This core and cladding is the main thing on the optic fiber cables. Remaining thing, what you are seeing physically, they are only the construction as well for which is used for the protecting this core and cladding. Throughout the world, optic fiber cable means it is going to have core and cladding, which is a pure glass material. Core is the purest form of the glass material. Cladding is the impurity form. In other words, if you want to tell in practical means, core is the 24 karat gold, cladding is 22 karat gold. It's like that you can have a comparison. They are going to have different refractive indexes. Core is the higher refractive index. Cladding is the material which is going to have some impurities and it is having the less refractive index. Always N1 greater than N2. Core refractive index is greater than cladding index. Light is going to travel only inside the core. The principle called TIR, total internal reflection. The cladding is used only for reflecting the light so that the light can travel only inside the core. Okay, this is you might be wondering how this is happening. From here to America, I'm sending 162 milliseconds and coming back. How much faster it is going? All these things are happening because of only one engineer. Narendra Singh Kapani, we can proudly say, he's an Indian. He's a physics graduate from Amritsar University. Okay, he is the father of optic fiber cable. He recently passed away in 2019. Okay, he is the man who behind this optic fiber cable communication. Because of him only, I'm communicating with you now without any delay. There will be some delay, but it's manageable. This much faster. It is possible only because of this huge mastermind behind that technology. Okay, but unfortunately, he was not awarded with any Nobel Prizes. His juniors were awarded with Nobel Prizes in case of optic fiber cables. So I can proudly say that he is the father of the optic fiber cables. Okay, what is the thing going to happen? Just this is now architecture overview of telecommunication. What is ISP network? Internet Service Provider. Okay, what is Internet Service Provider? For example, BSNL. BSNL is there. Okay, I'm going to provide some internet services. What is internet? Internet is nothing but an public transport network. That's all, sir. It's nothing more than that. Internet is nothing but a public transport network which is going to serve the customers. That's all. For example, Amazon, take the same example of Amazon. Okay, everyone will be having Amazon app in your phone. Okay, these are client apps. Okay, the client has to reach the destination. Destination is somewhere. Let us take an example. From here to Bangalore, if I want to travel, I'll be traveling in a public transport. That public transport might be connecting through network, a rail network or any other network like that. Internet is nothing but it's a public network which is connecting all the devices throughout the world through optic fiber cable. Apart from that, this fiber is used in different places. We can see what are those places and what is the advantages and why we preferring optic fiber cables. The small architecture. Okay, here I'm having an information called control plane. Okay, and this is this subscriber end. This is the subscriber end. Just a minute, sir. Okay. Okay, Satyendra Agarwal has given very good information. Optic fiber cable is having a high bandwidth as well as low loss. Yes, sir. What is bandwidth? Bandwidth is nothing but the information carrying capacity. If, for example, if I'm going to type, hello, how are you? And I'm sending you in WhatsApp. Okay, this information has to be transferred to zeros and ones. These zeros and informations, these zeros and ones are the information and they are going to contribute the bandwidth. For example, if my medium is having more bandwidth means I can carry more information, zeros and ones. If I'm having less bandwidth, I'll be carrying only less information. That is the bandwidth. Bandwidth is nothing but the information carrying capacity. For example, let's take an example of a cycle. Only 2 people can travel. If in case of car, the bandwidth is increased, 4 people can travel. If I'm taking a van, I can 15 people can travel. Bandwidth is increased like that. Is the carrying capacity. The optic fiber cable is having an unlimited bandwidth capacity, but it is restricted by the equipment what we are using. Okay, no one has find that full capacity equipment which can support the full capacity of the optic fiber cable. At the most, in current situation, we are transmitting up to 75 terabits per second in the Atlantic cables. Okay, from England to USA, 75 terabits per second at the most. But and practically they are tested up to 1.2 petabits per second in the optic fiber cable. That is the maximum equipment that I was able to manufacture to identify how it can transmit. That is the huge carrying capacity of the optic fiber cables. Any type of information, any type of bandwidth can support. Low loss, it can transmit to a longer distance. That means it is going to have low loss when compared to the other mediums. Other mediums in wired medium is copper cable. And compared to copper cable, so optic fiber cable is going to have enormous bandwidth as well as the loss is very less and much speed. It is having a lot of advantages than any other wired medium. This optic fiber cable is a wired medium. Yeah, but from that wireless medium also we are having. Any medium can be chosen, but preferably wired medium is the better medium. It can support you to the full bandwidth which you have chosen. Before that, you can see this small architecture ISP, that service provider. I am going to have control plane. This control plane is nothing but the servers. I'm going to have a lot of servers in my network. These servers are used to authenticate the customers. For example, if I'm switching on my modem will be sending information to this control plane servers. I'm having a AAA server. Okay, this AAA server will check whether this subscriber has paid the bill. Okay, whether this MAC ID is okay, all these things. Then only it will allocate an IP. What is an IP? Internet protocol, which is an identity which is used to identify a device in the network. It might be internet or it might be intranet. To identify a device, I'm going to have a logical address called IP. This AAA server will be allocating the IP. Then only my device is connecting to the internet. For example, if I'm having a cell phone, my cell phone, if I'm switching on my mobile data, immediately it will not get connected. Okay, the cell phone device will go to the tower. From that, it will be going to GGSM. From that, it is coming to PE router. PE router is nothing but a provider edge router. Okay, router means a layer 3 device in the OSI layer. This PE router, it is coming here. Then it is coming to the control plane. Here I will check whether the subscriber has paid. Okay, whether SIM card validity is there, whether he is having data plan, all those things I will check. Then I will allocate the signal to the GGSM. This GGSM, it will allocate the bandwidth what he has chosen, that bandwidth and IP address to this device. Now, after allocating the IP address, this device is connected to the cell phone tower. From there, through optic fiber cable, it is coming to PE router. And it is coming here to the main transmission equipments. After that, it is going to a router called IGR, Internet Gateway Router. Okay, this gateway router is in India. Okay, we are having in Chennai as well as Mumbai. Now in Trivandrum, Goa, the work is going on. Okay, this is the point where it is going to get connected to the internet. What is internet? Internet is nothing but a public transport network which is going to carry the information from one point to another. If you are not sending any information, then internet is nothing but it is an ideal network. No one is going to use. It is like our public road network during Corona period. No one was using. The toll gate was empty. The road, the bus were empty. Everything was empty. No use of that one. If you are traveling in the road, then only it is the usage. Like that, internet is nothing but a public transport network, which is going to transport the information from one point to another. It might be from your cell phone to the Amazon server. Example I have told. Apart from that, I'm going to have different devices. Okay, I'm having fiber to the home connectivity. then copper cables, all those things are getting connected. This is a copper cable, this is a fiber cable, all those things are coming to the PE router. In PE router, 1, 2, 3, three inputs I'm having, many to 1. I'm going to use a multiplexing in the PE router. Then it is coming to the common network. From there, I'm going to segregate to the internet. This is how the things are going to happen. Here you can see all the elements in the network are connected through optic fiber cable. Okay, that's why we are giving the preference to the optic fiber cable. In olden days, we are using copper cables. The maximum bandwidth can be supported in copper cable is around 1 Gbps, but the distance is very short. It can support up to only 15 meters. At the most, only 10 meters. 15 meters is in budgeting. Okay, if the speed is less, I can increase the distance. Yeah, that's why we have we are left with that copper cables. Now we are using optic fiber cable throughout the world. Now connecting different servers, server to server, which is very short. Let us assume less than 5 meters. The distance between the server also, they are getting connected through optic fiber cables. I told you an example. Sensors in the driverless car are connected through optic fiber cables. This is the importance of optic fiber cable. This is a small architecture, how the network is going to get connected. Okay, this is a transmission network. Okay, how the transmission is going to happen. These are the small, these are the end customers, bank, hospital, school, government enterprise. In the bottom, you can see. The bottom, you can see. These are the end devices. Okay, now from here, enterprises center A, enterprises center B, operation maintenance, all these things. For example, the school wants to get connected to enterprises center A. So hospital wants to get connected to enterprises center B. How I can get connected? For that, I'm going to have this ISP, comprehensive access as well as barrier network. These are the networks established by the ISP through different equipments, which is connected through optic fiber cable. Okay, you can see the optic fiber cables. We are having different equipments, but we are having different transmission equipments, SDH, OTN, IP, MPLS, MPLS, TP. These are the different technologies. They are transmission technologies. Okay, transmission technologies they are going to use to transport information from one point to another point. They are connected through optic fiber cables. This is how the data is transmitted throughout the world using optic fiber cables. Okay, telecom communication equipments. It can be broadly classified into three categories: public switching equipment, transmission equipments, customer premises equipments. Public switching equipments are analog and digital equipments. Transmission equipments, they are transmission lines, base transceiver stations, multiplexers, satellites, and etc. We have seen in transmission equipments, OTN, SDH, they are connected through optic fiber cables. Customer premises equipment might be a private switches, modems, and routers, and etc. The transmission and telecom, transmission equipments are nothing but just a transporter through which the data generated from one end is taken to the other end. Example, it might be a landline call, it might be a cell phone call, or it might be internet traffic. It's like a public transport bus. All people get in a particular source, multiplexing, that is many to one. After getting down the destination, one to many. Okay, this multiplexer and demultiplexing is going to reduce the cost. And telecommunication multiplexing is the main. If based upon this, you might have seen different types of multiplexing. TDM, time division multiplexing, which is used in layer 2 devices. In GSM, mobile communication, I'm going to use FDM, frequency division multiplexing. And in case of data networking, I'm going to use packet switching. Okay, I'm going to use optic fiber cables, WDM, wavelength division multiplexing, TDM, FDM, WDM. In case of optic fiber cables, I'm going to use WDM, wavelength division multiplexing. Why? Because light can be measured using wavelength. Okay, multiplexing and demultiplexing I have seen. Types of transmission mediums: guided medium and unguided medium. Guided medium is a wired medium, unguided is a wireless medium. Because of guided medium, you have twisted pair cables. Okay, and say an example of a LAN cable. Okay, the cables will be twisted. It's an RJ45 cable. Apart from that, we are having coaxial cable and we are having optic fiber cables. The preferred twisted pair cables can be laid up to 100 meters. Depending upon the speed, the distance can be varied. A coaxial cable can be laid up to 350 meters or 300 meters. Optic fiber cable can be laid without any amplification. I can send an distance up to 80 kilometers. You can see how much distance it can travel when compared to twisted pair cable as well as coaxial cable. Apart from that, I'm going to have unguided medium. There I'm going to use radio waves, microwaves, and infrared waves. Yeah, when preferring unguided medium, okay, please be careful using that, exposing your body to the radiations. This is an RJ45 twisted pair cable, registered jack 4 pair, 5 twist per inch. Okay, I'm going to have 4 pairs, that means 8 wires. There I'm going to use, for any communication, I require trans and receive. Now I'm speaking through my mouthpiece and you are hearing through your earpiece. That means trans, for me trans, for you receive. For you trans, for me receive, like that. 1 and 2 is trans here, 3 and 6 is receive here. Okay, 1 is connected to the receive, 2 is connected, 1 and 2 trans, another 3 and 6. 3 and 6 here, it is connected to 1 and 2. That is crossover cable, trans and receive. If it is connected straight, it is called a straight cable. Okay, in case of optic fiber cables, there are different types of cables based upon their constructions. Okay, here I'm going to use G652. This is standard, okay, for optic fiber cable communication, telecom communication, especially telecommunication. I'm going to use an G652, which is a single mode fiber, and it's a terrestrial cable. It's a single mode fiber, it's a terrestrial cable. We can see what is single mode, what is multi-mode. Here we can see in the coming slides. Telecommunication, preferred ITU standard is G652. Okay, it's a single mode. Telecommunication, we are going to use only single mode fiber cables. Previously, we were using multi-mode cables. Multi-mode cables are used only for shorter distances. Now, multi-mode cables, more or less, it's vanished from the field. Okay. Okay, apart from that, I'm going to use there are different types of laser classifications. Here I'm going to use classic 1M. The laser is 1M. Just a minute. I'm going to use some types of classifications, 1M laser classifications. You can see different classifications where we are using. Okay, in case of medical, we'll be using different types of classifications. Okay, it's recommended not to view the laser light directly with your physical eyes. Okay, it will cause retinal damage. Okay, please avoid projecting that laser lights, laser toys, lights directly to your eyes. It will affect your retina. The same thing will happen when you are exposing longer time to the LED, light emitting diode, which is in your cell phone. It will cause retinal damage. You might have heard about the Blu-ray. Okay, types of transmission equipments we are using: PDH, SDH, WDM, wavelength division multiplexing, OTN, CPAN. We'll be hearing about these slides and these equipments in coming sessions. Okay, though we are using different equipments, okay, I'm going to have a common medium called optic fiber cable. The optic fiber cable, if I laid one time, after that I can use any types of equipments. That is the advantage of the optic fiber cable. It can support any bandwidth, as one of our official told. Can use any type of bandwidth. Okay, this is how I'm going to convert analog signal to digital. For that, I'm going to use PCM, pulse code modulation, and that 64 kbps. Using Nyquist theorem, I'm going to derive 64 kbps. 64 kbps is the channel allocated to one single subscriber, a particular timing. In case of TDM, time division multiplexing. The PDH hierarchy. Okay, I'll skip these things just a minute. Okay, this is the SFP. Okay, when you are going to the field visit, we can see these equipments in the exchanges. Okay, this is called as SFP, small form factor pluggable. Okay, here you can see this is an electrical input. This is the electrical. You can see here. Here is the electrical input. Here this is the electrical input. Okay, the electrical input is given. This is a laser diode. It is a laser diode. It is a laser diode, and this is a photodiode. This is photodiode. Two types of equipment I'm going to have. This is electrical input. I'm going to give an optical output. This is the total structure of an SFP. Small form factor pluggable. Okay, what is inside? In case of transmission, I'm going to have TOSA, transmission optical subassembly. In case of reception, I'm going to have reception optical subassembly. Okay, you might be asking a question. In my home, I'm having only one single fiber. Okay, I told you in normal telecommunication for longer distance, we require two fibers, one in trans and another in receive. For me trans and for you it's in receive. For you trans, for me it's in receive for longer distance. For shorter distance, less than 20 kilometers, I can go with a single input. I can go with a single fiber. That is called as BOSA, bidirectional optical. The same thing is here. The single input. The single input. Okay, and this is an reception. This is the reception, and this is the transmission input. Okay, trans and reception will never mix. Why? Because they are going to have different lambdas. They will be having different lambdas. I can tell you an example. Different lambdas. What is different lambdas? For example, take water and kerosene. They are having different density. Having different density, they will never mix. Like that, if I'm using two different lambdas, they will never mix. And if I'm having a WDM filter, wavelength division multiplexing filter, I can segregate the trans and receive separately. Like a bird, we'll be telling that bird can separate water and milk when both are mixed. Like that, this WDM filter will be acting as a filter and it will separate the trans and receive. Okay. Okay, is there any doubts so far? Am I going clear? Anyone, if you can respond in chat also, please. Thank you. Okay, thank you, Satyendra sir. Okay, this SFP, we can see how that physical device is going to be. This is SFP. I'm going to have some specifications in the SFP. It's a 10G. It can support 10 Gbps. I'm going to transmit 850 nanometers up to a distance of 300 meters. All those things will be available. Here I'm having an arrow. Here I'm having an arrow. This is going to, it is pointing outwards. It is called as TX. Here I'm having an arrow. Okay, it is called as the reception. It is pointing inwards. This is SOP. It will be having specifications. Okay, with the help of the SOP, I'm going to convert electrical to optical, and then I'm going to connect to the connectors. You can see these are the connectors. This is the SOP. This is a single fiber. Here I have two fibers. In case of two fibers, I'm going to have a laser diode as well as the photodiode. Here, in case of single fiber, I'm going to have BOSA, bidirectional optical subassembly. I'm going to connect trans and receive in a single fiber. In case of different lambdas. Okay, and this is how I'm going to connect the SFP. Two fibers. I'm going to have two fibers. These fibers cannot be connected directly to the SFP. There I require an connector. There I require a connector. We can see what is connector, and we can why different connectors are used. You can see. Just remember, SFP is a device which is going to convert electrical signal to optical. That optical signals are transmitted through fibers, and it is going to the other end. There are other end, once again, optical to electrical. Why? Because telecom equipments can understand only the electrical signals. They cannot understand optical signals. That's why I'm going to convert electrical to optical and going to pump for long distance. And the other end, I'm going to convert to optical to electrical. This function is done by the SFP. SFP will be having specifications based upon the laser diode. 850 nanometers, 1310 nanometer, 1550 nanometer, 1625 nanometers, like that. It will be having specifications. Please remember, in both the ends, end A and end B, should be mandatory. It should be having same specification of the SFP. Okay, that lambda should not be changed. Both end the specification should be the same. For example, if I'm speaking in Spanish, no one can understand. If I want to communicate with you, I should speak with a common language. Like that, in both ends, the specification should be the same. Otherwise, that communication will not happen. This is a small introduction about the SFP. Okay, I'm going to have two fibers, one trans and receive. If for me trans, in the other end it will be receive. In the other end trans, for me it will be the receive. Okay, I'm going to have two sections, TOSA as well as BOSA, TOSA as well as ROSA. In case of single fiber, I'm going to have BOSA, bidirectional optical subassembly. This is the specifications on the SFP. I'm going to have BOSA. In case of BOSA, I'm going to have a WDM splitter, wavelength division multiplexing splitter. Okay, you can see a small introduction. Need for optic fiber cables. The OFC constructions, cable identifications, connectors, meters used, tools used, laying of optic fiber cables. We are going to see these things. Now, from here on, so I will be rushing a little bit. More bandwidth can support different bandwidths, low cost, low loss, less number of repeaters. So, what is repeaters? We have seen an example from here to USA. Miles of kilometers the cable has been laid. Okay, now this after particular distance, the optic signal will be diminishing. Okay, the power will be reduced. Once again, I have to increase the power. For that, I'm going to use repeaters, amplifiers, regenerators. In that amplifier, we are going to have an amplifier called EDFA, erbium doped fiber amplifier. You might have heard about Raman effect. That is the technology behind EDFA, erbium doped fiber amplifier, which can pump the signal up to 1500 kilometers. I'm putting an amplifier in a particular point. From that point, it can pump the signals up to 1500 kilometers. After that, once again, amplifier will be there. Like that, the signals will be pumped. For that, we are using the repeaters. Since the optic fiber cable can send a distance up to 1000 kilometers, the number of repeaters and network will be reduced. Electromagnetic immunity. It is an this is the special thing in case of petroleum refinery products of industries, as well as for monitoring that petrol pressure, that crude oil pressure from pump, that rig well to the refining unit. All those things, sensors, all those things are connected through optic fiber cables. Why? Because the electric immunity, magnetic immunity, they cannot affect the fiber, so that uh, fire accidents are reduced. Okay, this optic fiber cables can be laid along the power supply cable inside our house also. That is the advantage of this optic fiber cables. Small size and lightweight, greater safety, no electric hazards, higher security. Okay, if I'm cutting the fiber, immediately the total network is down. I cannot go for tapping of the data. The types of optic fiber cables. These cables is classified into two, indoor as well as outdoor. While using so inside the indoor, okay, they are more flexible. That cable is more flexible because I have to take through the walls. I have to take, there'll be more bend. I'll coil, all those things will be happening. Okay. I'm going to have indoor tight, that they're called as tight buffer. There will be single fiber. That fiber will be protected with Kevlar materials and FRP materials. Okay, it can be classified. Indoor cables are classified into two: pigtail and patch cord. So what is a pigtail? One end connector and another end it is free, so that I can go for a splicing. That is called as pigtail. What is a patch cord? Two end connectors. In the next slide, I can show you. I'll show what is a pigtail and patch cord. Okay, pigtail means one end connector, and the other end it is an normal open side where I can go for a splicing with the outer cable. What is a patch cord? Two end connectors. I will show in the coming slides. Okay, outdoor cables are called as loose buffer. They are classified into drop cables as well as feeder cables. Feeder cables are the main cables. Drop cables are the cables which are used to tap from the main cable. We are having different types of size of cables: 24F, 48 fibers, 96 fibers, 144 fibers, 288 fibers. In a single cable, I can have 288 fibers. For example, if I'm having 24 fiber mains, I can connect only 12 equipments. Why? Because and each and every equipment will require two fibers for long distance. Each and every equipment will require two fibers, one and two for trans, like that. In case of drop fiber cables, I'm going to have different sizes: 2 fibers, 4 fibers, 6 fibers, 12 fibers. They are less in size and they are more flexible, so that they can taken through the overhead lines. Feeder cables normally they are buried in the underground. Okay, main point to point areas, and it is buried in underground. From the underground, I will be going for dropping. That dropping, this is the drop cable which is coming to your home. It's called as the drop cable. They are less in size numbers. They are less in numbers: 2 fibers, 4 fibers, 6 fibers, or 12 fibers. We are having two types: indoor fiber as well as outdoor fiber. Indoor fiber are called as tight buffers. Outdoor cables are as loose buffers. Indoor cables are called as pigtail as well as patch cord. Outer cables are terminated as feeder cables as well as uh, drop feeder cables. Okay, based upon the construction, I'm going to have single mode as well as multi-mode. Okay. In case of single mode, I'm having a small white round here. Here I'm having a small white round. In case of multi-mode, I'm having a big white round. This is called as the core. This is called as the core. It's called as the core, and this is the cladding. This is the cladding. Okay, this is the core and this is the cladding. Okay, here the cladding is same in size. You can see it's 125 micrometer. Here also 125 micrometer. The cladding size is the same, but the core diameter is less. In case of multi-mode, I'm going to have a greater diameter. In case of single mode, I'm going to have a smaller diameter. Now you tell me, sir, let us assume these two are water pipes. These two are water pipes. Okay. Now assume these two are water pipes. Okay, now I am going to pump the same pressure of water in these two pipes. I'm going to pump the same pressure of excuse me, and in two pipes, I'm going to send the same pressure. Okay, one is having a smaller diameter and another is having a bigger diameter. Now you please tell me, sir, which pipe will be pumping the distance of water to a longer distance? Which pipe will be pumping the water to a longer distance? Smaller diameter or bigger diameter? Okay, Satyendra sir has told smaller pipe. Okay, let's assume when you are going for a water wash, you'll be having a sharp nozzle so that the water pressure is more. Like that, when the core diameter is very small, the signal can be pumped to a longer distance. That is why we are using single mode fiber in optic communications. Okay, the core size is very small and the cladding is 125 micrometer. Please remember, light is going to travel only inside the core. Clad is used only for reflecting the light so that the light can be traveled in the core in the principle called TIR, total internal reflection. That is why multimode fibers can be used up to 2 kilometers. That can be used up to 2 kilometers and single mode at least up to 60 kilometers without any amplification. Okay, that's the advantage of single mode as well as multi-mode. Now you should have understood. Okay, difference between single mode and multi-mode, higher bandwidth and lower bandwidth, distance up to 60 kilometer plus. Here I'm going to have a distance up to 2 to 5 kilometers. Best for telecommunications, WAN access network. Best for LAN, SAN and data centers. The multi-mode cables are used in data centers. For example, we can say it as an Google data center. There will be acres of land and a lot of servers inside that data center. They are connected through multi-mode cables for shorter distance, no issues, and I can go for the same type of data. Okay, the principle of the uh, optic fiber cable is going to work in total internal reflection. Okay, I'm having a light source. Light is going to come in 0 degree. It will be, for example, assume, okay, from here to here is the core. Is the core. Okay, after this, here I'm having water medium. Here I'm having air medium. Assume these are two different mediums. Okay, this having a refractive index is more, and if it is having a refractive index is less. Air is having a refractive index less. If I'm sending in light in 0 degree, light will be going away. If I'm sending to 20 degree, it will be bending. It will be then when the light is sent after 45 degree, greater than 45 degree, okay, the light will travel inside the core. Here I'm having air medium. Once again, it will get reflected. Once again, it will be coming here. Once again, it will get reflected. Like this, it will be traveling. Like this, it will be traveling. This is called as total internal reflection. For getting total internal reflection, the incident angle should be greater than 45 degree, which is called as the critical angle. Which is called as the critical angle. The critical angle should be greater than 48.8, approximately 45 degree. It should be greater than that. And I should be having two refractive indexes, mediums. And it is going to work in a principle called total internal reflection. Okay, it's a demo for an total internal reflection. This is a VFL, visual fault locator. If I'm putting a laser, it is going to generate 650 nanometer visual light. Okay, this is a 650 nanometer visual light. What LED screens in your phone are going to emit is 500 nanometers. Please remember LED TV, LED lights, LED display, everything is going to emit 500 nanometer, which is the Blu-ray. It will affect your retina also. This is an VFL touch. It is going to emit 650 nanometer. It's a visual light, which is used in the toys where kids are using. Okay, I'm putting this is a water, tumbler of glass of water. Okay, I'm putting light in a particular angle. Light is going to travel once again back. If the angle is greater than 45 degree, it will be bending. You can show a demo to our kids also. This is the construction of the optic fiber cable. Thus, I'm going to have a core. This is a multi-mode. If it is single mode means it will be 9 micrometer. This is the core, 62.5. After that, I'm having the cladding. Please remember, these two are only the optic fiber cable. Remaining things are used only for protection of this core and cladding. You can see the core and cladding. Okay, I told you pigtail and patch cord. In the indoor cable, we are seeing two types, pigtail as well as patch cord. This is a connector and this is a bare end. You can see this is a connector and this is a bare end. This is the bare end. Okay, where I'm going for a splicing with the outer cable. Okay, here I'm going for a splicing. Here I'll be going for a splicing. Here in case of patch cord, I'm going to have two end connectors. Okay, I'm going to have two end connectors. Okay, this is an yellow color and this is an orange color. You can see. Okay, you can see. If it is in yellow, it is an if it is in yellow, it is a single mode. And if it is in a red or a orange, it is an orange, it is a multi-mode. It is a multi-mode. You can see. If it is an orange, it is a multi-mode. Based upon the colors, we can identify whether it is a single mode or multi-mode cables in case of indoor cable. Okay, if it is having one end connector, it's called as pigtail. If I'm having two end connectors, and it is called as a patch cord. Based upon the color coding, you can identify the construction of the core and cladding, whether it is multi-mode or single mode. Never mix multi-mode and single mode cables. Okay, we should not mix. It will not work. This is the color coding. Okay, we can see why you refer the color coding. You can see. For example, I'll tell you a small example. If you're having a fan, electrical fan, which is running fine in the morning, okay, and a rat has bitten the cable. A rat has bitten the cable. Now I want to join the two wires. Okay, phase and neutral. Okay, now I want to join. How I can join? How can I identify phase and neutral? Based upon the color. If it is in red means it is in phase. If it is black means neutral. Depending upon the color, I will join. I will remove the sleeve and I will be joining the copper and copper. Then I will be putting an insulation tape. The same thing I am going to use in the optic fiber cables. Please remember, core and cladding, they doesn't have any colors like the electrical wires at your home. The copper, both are same. In case of phase and neutral, both are same. Copper is same. How I can identify? Based upon the coating given upon the copper cable. Like that. Here also, core and cladding is going to be the same. I want to identify which is the first fiber, which is the second fiber, which is the third fiber. If there's a cable cut, or else if I want to terminate the cable, then I have to identify which is the first fiber, which is the second fiber, which is the third fiber. For that, I'm having a standardized color coding which is used throughout the world. Okay. For example, if I'm having an outdoor cable, there's a cable cut. Okay, that's a 12 fiber. Then I want to join. Then I will be going for the same color coding. This side blue, that side blue. This side orange, that side orange. That means I'm going for a straight joint. Okay, that is the requirement of the color coding. This color coding you can see here. Okay, this is color coding. This primary buffer is there, no? This primary buffer. This primary buffer is the color coding. Core and cladding, it doesn't have the color coding. This primary buffer is going to have the color coding. This color coding is common throughout the world. Color coding is common throughout the world. This color coding is common throughout the world. They are blue, orange, green, brown, slate, white, red, black, yellow, violet, rose, aqua. This color coding is the standard throughout the world. This is the loose tube. Okay, you can see this tubules. I can see here. You can see I'm having a color coding in this tube also. Apart from that, inside the tube, I'm having blue, orange, green, brown. Okay, that means For example, this is an 3LT 6 fiber. Let us assume this is a 3LT 6 fiber means this 3LT represents how many buffer I'm going to have the fibers. Okay, in 3 loose tube, I'm going to have 6 fibers. That means 6 divided by 2. In each and every buffer, I'm going to have 2 fibers. In each and every buffer, I'm going to have 2 fibers. That it will be in blue and it will be in orange. Blue, orange. It will be, one will be in blue and another buffer. I'll be having blue and orange. Another buffer, I'll be having blue and orange. Here also blue and orange. Here also blue and orange. Here also blue and orange. Now you tell me which is the first buffer, which is the first fiber, which is the first buffer. For that, I'll be going for another color coding: blue, orange, green. Blue, orange, green. That means blue is the first buffer, orange is second buffer, green is third buffer. In case of blue, I will be having blue fiber as well as orange fiber. In case of orange, I will be having, and this is the fiber number 1, fiber number 2, fiber number 3, fiber number 4, fiber number 5, fiber number 6. This is how I am going to identify with the help of the color coding. Okay. Do you want to repeat this one? Or you are comfortable with this explanation? Do you want to repeat this color coding, or are you comfortable with the explanation? Okay. Just a minute, I will go for another next slide so that I can understand easily. Okay. Okay, let us assume 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Here I'm having 4 fibers. Here I'm having 4. Here I'm having 4. Let's assume there's a cable cut. Here also I will be having. Here I will be having blue, orange, green, brown. Here also I will be having blue, orange, green, brown. Here also I will be having blue, orange, green, brown. Okay. This is an in each and every buffer I am going to have 4 fibers. Okay. Now, if I am not having this color coding blue, orange, and green, if I'm not having this color coding, the outer color coding, this color coding, what I'm speaking about is color coding. If I'm not having this color coding, blue, orange, and green, then all the fibers will be the same for me. For example, in all the buffers I'm having, how I can identify? This is the first bunch, this is the second bunch, this is the third bunch. How I can identify means the help of the color coding of the buffer. Assume this buffer is like your earbuds tube. There is no, in the earbuds we're having a tube. Okay, inside the tube, I'm going to have hair follicles. Let us assume inside that bud, I'm going to have 4 hair molecules. Okay, another bud is there. I'm having 4 hair molecules. And another bud is there. I'm having 4 hair molecules. How I can identify which is the first hair molecule, which is the second hair molecule, or which is the first bunch or the second bunch? For that, we are going to have the same color coding, which you have seen. First buffer, that buds I told you, that is a buffer color coding. Inside the buffer, I'm going to have hair molecules. Those hair molecules will be given with different color coatings: blue, orange, green, and brown. Each and every buffer I'll be having. This is not the standard. The color coding is the standard, but this standard might be varying depending upon the specification or the construction given by the vendor to the manufacturers. In a single buffer itself, I can have 48 fibers. That 48 fibers will be having 12 bunches. So not 48 fibers will be having 4 bunches. First bunch will be binded with a blue ribbon. Second bunch will be binded with an orange ribbon. Third bunch will be binded with a green ribbon, like that. Okay, when I'm opening that blue ribbon, there I'll be having 12 fibers starting from blue to pink. That 12 fibers will be there. Why? Because this color coding is the mandatory one, which is used for identifying the fibers, which is mainly used in splicing. When there's a cable cut, or if I want to make a T-joint, if I want to make a joint in the main cable, if I want to tap something in another area, if I want to take the information from one point to another point by tapping, for that this color coding is the mandatory one. This color coding is blue, orange, green, brown, slate, white, red, black, yellow, violet, rose, and aqua. Okay, we are having two types of color coding. One is the first, the buffer. Buffer is used to identify the bunch. In each and every buffer, I will be having once again number of fibers color coding based upon the construction of the fibers. Okay, sir, I got a little bit. Sir, okay, va? The main thing is to identify the fibers, basically. I told you an example, no, to identify which is the phase and which is the neutral based upon the color coding. Okay, sir. Sorry to say this. In a single day itself, you cannot. I cannot load you with the more things. Okay, still a lot of slides are there. Okay, thank you, sir. Thank you for your cooperation. Okay, this is how you can see another type of slide I have given you. Okay, this is a blue, orange, green, brown. Here, once again, you're having the fibers, blue, orange, green, brown. Okay, now we might have got a little bit more clarification when compared to that slide. Okay, so these are different connectors. Okay, I told you that fiber cannot be directly inserted in the laser diode. And from the laser diode, I told you it should be in a particular angle called critical angle. Okay, so that it will be traveling inside the core. For that, ensuring that it is coming in critical angle and it is entering the optic fiber cable. For that, we require the connectors. Connectors are the important one, which is going to collect the laser from the laser diode and it's going to pump into the optic fiber cable. Okay, here you are having different types of connectors. Okay, E2000 APC is an angle polished connector. Okay, you can see green as well as blue. Most preferred is the green one. In the case of field, if you are seeing green one means green one is the important one. It's an angle polished connector. Here it's an ultra polished connector. Here I'm having a physical connector. Different types of connectors are here. E2000 square connectors. This square connector is used at your home. This square connector is used at your home for getting the fiber to the home. Okay, this is used. These two LC as well as this E2000 are used in the equipment termination. When you are going to field visit, you can see this LC as well as E2000. E2000 will be rarely used in the field. Okay, it is more costlier and it is used in DWDM equipments. This is in DWDM equipments. This LC is normally used. This is not used at present. Ferrule connectors. Okay, they are having huge loss when compared to LC. LC E2000 is number 1. LC is number 2. Square connector is number 3, and this is number 4 based upon the ranking. Remaining things are we are not using in any other places. Okay. These connectors are used to collect the laser and once again to pump into the fibers. Okay, here you can see here I see orange as well as yellow. Okay, you should not mix at any cost. You should not mix orange as well as yellow. Okay, the connectors with different boots. Here, this is the boot. This is the boot. This is the boot. This is the boot. Here is one boot. Here is one boot. Here, they're having different boots. You can see this is a square connector. This is a square connector. This is also square connector. This is also square connector. You can see they are having different colors, blue, green, different colors are there, and having different boots. Here one boot, here one boot, here one boot, different colors. Each and everything is going to have specific values. It's not like that they are given the color coding. They are having specific values. It is the boot, the color jacket as well as boot. What is the important thing? You can see what is APC and UPC. Okay, in case of APC, the connector tip is like this. It is in a particular angle. In case of APC, it is in a particular angle, so that the light coming in a particular angle can totally get inside the fiber and it will be traveling like this. Here, in case if I am coming here means some light will be lost here. It's not the exact value. In case of something will be lost here. That is the preferred is APC. It is going to have very less back reflection. Okay, we will be telling us an insertion loss. Okay, in case of a technical term, we'll be saying as insertion loss. Okay, in case of APC, I'm going to have a different, very less insertion loss. That is the green. It is a green boot. That is in case of green boot, I'm going to have very less insertion loss so that it can travel to a long distance. The cost of this APC is a little bit costlier when compared to this flat. Okay, alternators are nothing but like our resistor. Okay, what resistor will do? If I'm having more power, I have to reduce the power. In that case, I will be putting resistor. Likewise, alternators. Any optical device will be having an optical power range. For example, minus 11 dB to minus 28 dB. If my power is more than higher than minus 11, example, let's take it as minus 10 dB, the equipment will not work. Likewise, if my optical power is very less than minus 28, like 29 to 30, in that case also it will not work. Okay, in that case, what I should do? If I'm having an equipment which is nearer to me, okay, my optical power will be more. Then I have to reduce the optical power. For that, I'll be going for an alternators, like our resistor. Alternators can be sometimes can be called as an sometimes can be called as an connectors. Okay, if they are putting if they are generating only 0 dB loss, for example, just a connector without any loss, they can connect, used to connect. You can see this is an example of an I could show you. This is an example of an alternator. This is an example of an alternator. Here one alternator, here one alternator. Okay, they are going to generate 0 dB. They are going to generate 0 dB. That is no loss, just to connect different cables. Okay, you might have seen it at your home. Okay, the cable will be terminated to the connector, alternator, then you'll be terminating the cable. Like this also you can see. Alternators are nothing but to reduce the power as well as to connect the different patch cards from one to end to another end. Apart from that, I'm having a variable alternator. It is like our rheostat. Okay, if I want to find the characteristics of a device, okay, I'll be varying the optical power resistance now using rheostat like that. I'm going to vary the optical power to identify. This variable alternator can be used while installation of a new telecommunication equipment. Apart from that, fixed alternators are used in the normal field. You can never mix this square connectors as well as. Okay, this is the important thing. Never mix blue as well as green. Single mode as multi mode like that. Never should not be mixed. Both should be the same. This is the incorrect one. This is the correct one. This is the alternator. You can see this is the alternator. This is the alternator. You can see two ends I'm going to connect. Okay, when you're going to the field visit, you can see all those things. This is a splitter, 1:2. Okay, normally, what is a splitter? I'll tell you. For example, if you are getting a water pipe connection, okay, if you want to divide it into two homes, okay, one pipe is coming. If you want to divide into two, okay, what happens? In that case, the water pressure is reduced. but water is not reduced. Water pressure is reduced, the quantity is reduced. Likewise, when optical power is splitted, there will be some loss. That is called a splitter. In case of our telecommunication, we are going to have passive splitters. Okay, that doesn't require any power supply. Like a small prism device will be there. If I'm giving a single input, I am getting two outputs. That's called as splitters. This is how I'm going to connect using a media converter. Okay, for longer distance. Okay, for example, you are having an fiber connectivity at your principal room. From there, if you want to take it to hostel, boys hostel means, for example, the boys hostel is around 1 kilometer away from principal room. Then I cannot lay the LAN cable. Why? Because this LAN cable can be used up to 100 meters. Then I'm going to use an electrical cable to and this media converter. This is the 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 media converter. Okay, from here I'm going to give an electrical input. From here I'm going to use an optical output. This is an SFP. One is trans and another is receive. This is one instance, another is receive. And other end I'll be terminating like this, trans and receive, and I'll be taking to the other end from RJ45. I'll be giving to the computer. This is how I'm going to communicate. Why? Because LAN cable can be laid up to distance of 200 meters at the most. Preferable is 100 meters. At the most, I can lay up to 200 meters in case of LAN cables. And now here scenario is 1 kilometer. How I can take? I can take through optic fiber cables. For that, I require a media converter. The cost of this media converter is around two require pair, no? It is around 5,000 rupees. Okay, this is a giant closure. You might be seeing on the roadsides. Okay, here you can see the color codings of the fiber. Okay, here you can physically it is visible. Blue, orange, green, how they are tapping. Here in case of blue, I am tapping with some other color. That means it is an T joint. Where I am going for a T joint. If it is straight joint means it will be the same color coding. Okay, this giant closure. This giant closure is going to have some cassette. This is called as cassette. Okay, here is one cable. You can see the one end and the other end. Two ends are there. I have removed all the things. I am having this the buffer. I told you, this is the buffer, plastic buffer. This is the plastic buffer. Plastic buffer. You can see the plastic buffers. Plastic buffer. Then I am taking from the buffer. I am taking the fibers and I am going for jointing. Okay, this is the use of giant closure. This is an this giant closure you might have seen in your on the roadside for cable T operators. It is around 50 rupees only. Okay. This is an OTDR. OTDR is nothing but an optical time domain reflectometer. Okay, it is used to identify where the cable is cut, as well as where the joints are available, what is the distance of the cable. All those things can be identified using the OTDR. OTDR expansion is optical time domain reflectometer. You can wonder how you can identify. Okay, it is going to get an principle called back reflection. Okay, if there is a splice, it is an non-reflective event. If there is a connector, or if there is an SFP, or if there is any other patching, it is an reflective loss. Reflective loss, it will be in spike. In case of non-reflective loss, it will be in a Z shape. The help of that I can identify. There will be a graph, and I will be having a cursor. And I will be having a cursor. I can move from the graph so that I can identify the distance. The accuracy of this OTDR is plus or minus 5 meters. For example, if there's a cable cut means from my point, for example, it is showing 45 kilometers means exactly it might be 44.95 or 45.05. Exactly like that meters it will be showing. Okay, length of the optic fiber cables, distance of the optic fiber break, loss in dB, number of splices, connector loss, all those things I can see. This is how I'm going to have the traces. I'm going to have, as I told you, there are two types of traces, reflective trace as well as non-reflective traces. This is the meters. Optical source meter, this is optical power meter. This optical power meter is like our multimeter. Okay, our multimeter, what you can measure? You can measure the voltage level, receiving voltage level. Okay, like that, the optical power meter is used to measure the received optical power. I told you, the every equipment is going to have particular value, optical power value. It should be within that limit. Let us take an example of our television at our home. Okay, our television, what is the operating voltage? It's 180 volt to 230 volt. If the voltage is very less than 180, it will not work. If it is going more than 230, it will burst. Likewise, any transmission equipment or optical device will be having particular optical power range. That optical power range can be measured using this optical power meter. The source meter is used for testing a new cable. Okay, when I'm going for an acceptance testing of a new cable, I'll be using the source meter. And this optical power meter is the meter which is used frequently in any optical network for maintenance purpose. The visual fault locator. Okay, it will be on the previous slide we have seen now on glass tumbler of water. We are putting our laser light 650 nanometer physical light. It can be detect the cable. If there's any, this is mainly used within the indoor cable, as well as to identify. There is no labeling here. You can see a lot of cables are here. Lot of cables are here. I want to identify which is the other end of this cable. Here, for example, I'm putting on connector, and if I want to identify which is the other end in this bunch, then I can put this VFL. If I'm putting light, it will be showing the other end so that I can identify and go for labeling. It can travel up to 15 kilometers. This VFL light can travel up to 15 kilometers. It is going to use 650 nanometer visual light. In telecommunication, we are using 1310, 1550, which are invisible laser lights, which can cause huge damage to your eyes. That is why it is recommended not to directly view into the SFP device or any laser equipment devices. Okay, why? Because they are going to generate invisible 1310 or 1550 nanometer, which is more dangerous to your retina. Retinal damage cannot be rectified. Lens damage can be rectified. Retinal damage cannot be rectified. Therefore, please be more careful while working with optic fiber cables. This is a device where I can find where the laser is going or not. This is how I'm going to test. After splicing, I'm going to test with an optical power meter. These are the different tools used for splicing. Okay, I told you an example of a fan. Okay, if the cable cut is there, then I have to remove the insulation on the top. Then I will be going for connecting copper. What I'm going to connect, I'm going to connect copper with copper. I have to remove the remaining things. For that, I need a stripper or a cutting blade. Likewise, here also, I require different tools for removing the unwanted things, and I'm going to expose the cladding, and I'm going to join the cladding and cladding. Then I'll be protecting. These are the different types of this is 1 to 3 cutter. Now I will be saying 1 to 3 cutter. Here I'm going to cut the buffer. Then I'm going to remove the primary coating. All those things. This is an exactly primary coating remover. Primary coating, I told you the color coding. After removing that color coding, it is only the cladding, which is a transparent glass material. While working with cladding, please be more careful. Why? Because it is a glass material. It can penetrate into your body or fingers, and it can travel through your veins and arteries. And no X-ray machine or ECG machine can identify that small pieces. Okay, until primary coating is removed, no issues. After removing the primary coating, please be more careful. As an engineer, when you are seeing this optic fiber cable, there's a cable cut and it is laying on the road, please wind it up and keep it away from the public. For different, sometimes it may hurt some people or it may hurt some animals also. Okay, when you are seeing some cables, please wind it up and keep aside of the road. This is a buffer cutter. This is an interstable, different types of tools. When you are going for splicing, no, all those tools are required. Here I'm going to cut the outer sheet. This is the buffer. You can see this is a buffer. I'm going to cut the outer sheet and inner sheet. Then I'm going for the buffer cutting. Then I will going for primary coating remover. Okay, the different tools used, and this is the cleaver. Finally, I want to cut that cladding into exactly 90° so that I can joint. Let us take an example of our water pipe. If there's a water pipe cut, what you will do? You'll be putting a coupler in the middle. For that, what you will do? The both ends you should be having exactly 90° so that it will be going and fitting inside the coupler. Like that, here also, if there's fiber cut means that end will be irregular shape. Now I want to exactly cut 90°. The help of the cleaver, I'm going to cut exactly 90°. That is the purpose of the cleaver. After cleaving, I'm going to keep inside the splicing machine. Here, this is the 2 ends I'm going to have. Okay, this is a splicing machine. I'm going to keep it inside the splicing machine. The splicing machine is having the splicing machine is having the splicing is having a 2-axis motor, x-axis as well as y-axis, and it will be having a camera. All those things is available inside. It will be aligning automatically. It will be showing the camera. It will be showing. Here you can see this is the camera. This is the fiber, 2 ends. This is the 2 end fibers. This is the camera which is showing. Okay, after splicing, what I'm going to do? I'm going to remove and I'm going to put in the sleeve. Like in case of electrical fan, I told you, you can put insulation tape or you can go for a thermo shrink sleeve. That thermo shrink sleeve will be fitting perfectly to that copper cable so that any water can be going inside. Likewise, the sleeve is used to protect the cladding and cladding. This is a ribbon fiber. 12 fibers will be combined in a single strip. It's a ribbon splicing machine. This is how I'm going to take to the indoor fibers. Okay, it should be taken through a steel pipe recommended. Why? Because rat and squirrel, they'll be biting the fibers easily. This is throughout the world how the fiber cable is laid. Okay, underground sea cable. How? Please remember, underground sea cable also going to have only the core and cladding, but the protection is going to be heavier. If it is inside the deep sea, it is very less protected. If it is near the seashore, it is more protected. This is how I'm going to take the cables. Okay, end to end. This is jointing, temporary jointing, all those things. Just for your explanation, I give. From equipment to FDF, I'm going to have patch card. From FDF to outer cable, I'm going to have pigtail. Here I give the diagrams, how the FDF will be looking, all those things. When you're going for the field training, you can see these things. This is a cable termination. Okay, normally this cable is kept in a coiled manner. Why? Because when I'm not keeping in coiling manner means the light will go away. That there will be heavy loss. Here also I'm having in a particular coil manner. Please remember in indoor cable, the coil should be at least 1 hand span. The diameter of this coiling should be at least 1 hand span. The different types of terminations and how I'm going to lay the cables throughout different case of different trenches. Okay, I have given the slides. These are different types of joints. How I'm going to use the joints. The images I have given you. The joint indicator and root indicator. Okay. With this, we can come to a conclusion. I'll be sharing this slide with you. Okay, sir. If you're having any doubts, you can ask me. It's a free open session now. I cannot pump more information, so it's a very short duration.
Sir, very good session, sir.
Okay, sir. Thank you, sir.
Sir, is there any alternative for OFC, sir?
Now we are going for photon communication, sir. Now, photon communication is emerging technology. How copper cable was eliminated from our world, this optic fiber cable also one time it will be eradicated, like that they are telling. When photon communication is coming into picture, it will be happening.
Okay, sir.
Thank you. Is there any other questions, or else you are free to leave the session? Thank you.
Sir, nicely presented, sir. Thank you.
Thank you, sir. Thank you, sir.
We are happy.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Thank you.